Hello there, Mr. Sutton here, bringing you the IM3 Honors 4-2 lesson on completing the square. In this one, we're going to solve quadratic equations using the square root property and the very closely related process of completing the square.
For the warm-up, we are being asked to solve this quadratic without factoring. So the key situation here is a quadratic equation that doesn't have a linear term. Notice there's no x to the first power anywhere in here, unlike the ones we've done before. These can actually be solved by isolating and square rooting the quadratic term. So in other words, basically just getting x squared by itself on one side, some number on the other side, and taking the square root. So with that in mind, see if you can go ahead and solve this equation by square rooting. All right, if I want to get x squared by itself, I need to subtract 3x squared over to the left side, giving me 8x squared. And then I divide both sides by 8 to get x squared truly by itself, so that's 20 on the other side. And at this point, since I've got x squared by itself, I'm ready to square root both sides. Now, when I do this, I actually have to write a plus or minus right next to that radical 20. We need a plus or minus when square rooting equations. It's not built into the square root, but when you're square rooting an equation, you're asking what could I plug into x squared to get 20? Well, whatever the square root of 20 is, that would give me 20 if I plugged it into x squared, but also the negative square root of 20. If I squared it, because a negative times a negative is a positive, that would also give me 20. So we need a plus or minus in this situation. And now just simplifying things, we have just x on the left side, and on the right side we can split this radical up a bit and put it in simplest radical form. So this can be rewritten as 4 times 5 inside a square root, which gives us plus or minus 2 radical 5. Here's another example for us to try out. So the process of solving by square rooting can actually be used in this situation as well, where you have x inside a squared parentheses. Pause the video and see if you can use square rooting to get to the bottom of this one. All right, now just like before, we need to isolate the squared thing. In this case, we need to subtract 6 and then divide by 9, so that's a negative 5/9 on the right side. And now that we have the squared thing by itself, we can square root both sides. So that'll give us just x minus 1/3 on the left side. And on the right side, there's a whole bunch of things going on. We have to use the plus or minus because we square rooted an equation. We have a negative inside the square root, so that's going to give us an I. And then we have radical 5 over the square root of 9, which we can call 3. So when the dust settles, that's plus or minus I radical 5 over 3. And we're almost done. Just one more thing. We have to actually get x by itself by adding 1/3 to the other side. Since we have two fractions, both with a denominator of 3, we can actually combine that so that we have 1 plus or minus I radical 5 all over that common denominator of 3. So here's where it gets a little trickier. This problem, we definitely do not have a perfect square trinomial. Even if you add the 10 over here, you're not going to have one of those perfect square sandwiches. So what do? Well, we're going to kind of force the issue. I'm going to rewrite this so that I have a little bit of space between the 8x and the equals, because in this space I just made, I'm going to put a magic number. I'm going to put a number that when I put it in here, gives me a perfect square trinomial. But what number should I put in here? How do we synthesize a perfect square trinomial? Well, to figure that out, we're going to play a little game over here on the left called Let's Make a Perfect Square Trinomial, right? For lack of a better name. Here's a perfect square trinomial, x squared plus 10x plus 25. If you take the time to factor this, this is x plus 5 quantity squared. Here's another one, x squared plus 12x plus 36. That's x plus 6, the whole thing squared. Here's another one. What does this one factor into? You got it, x minus 7 quantity squared. Here's another one. Oh, wait, we're missing a number here. So pause the video, take a look at the perfect square trinomials you already have here, and see if you can predict, based on these numbers here, and just using this negative 16, see if you can predict what this number ought to be. All right, so hopefully you picked up on the pattern, where to get this number, you just need to take half of this middle number and square it. Half of 12 is 6, square that, you got 36. Half of negative 14 is negative 7, square that, you got 49. Half of negative 16 is negative 8, square that, we got You got it, 64. So that's the process we're going to be following to create a perfect square over here. We're going to take half of the coefficient of x, which in this case is -4. We're going to square that. And because this is an actual equation and we can't just change one side without changing the other, we're going to add that -4 squared to both sides so that we're keeping it legal. Now, you might wonder, why didn't I just make this a 16, right? I mean, I know it's 16. I could have done that in my head. Well, I'm leaving it as -4 squared for a few reasons. One is so you can see where it came from, but the other is that on my very next step, I'm just going to factor this thing anyway into one of those squared binomials. So there's no point in making it 16 if I'm just going to un-16 it on the next step. Also, we know that this is going to factor into x minus 4 quantities squared. If I leave it as -4 squared here, I have the thing that I'm putting inside staring me in the face, and it's a lot easier to make this step here. All right, let's keep going now. So on the right side, we're going to have -10 plus 16. Now, why did I bother making it 16 over here? Well, I need to add these together and simplify this to keep going in the problem. So I'm going to let you keep going in this problem. Pause the video and take a minute to solve this by square rooting. All right, let's see how you did. So first, hopefully you combined the stuff on the right to get 6. And then square rooting both sides, we're going to have x minus 4 equals plus or minus square root of 6. We still need to get x by itself, so let's add 4 over here. So we'll have x equals 4 plus or minus radical 6. And that is our answer. Now, this does have the advantage that you didn't need to factor at all, and honestly, this equation, you could not have solved this by factoring. You'd be trying to find two things that multiplied to 10 and added up to -8. But this process of completing the square allows us to solve the quadratic anyway, and that's pretty cool. So now that we've seen the process for completing the square, we're going to practice it and add a few more layers. In this problem, two key differences. One of them is that we have this constant over on the left side. In the last problem, it was on the right side, so we had a nice little space here before where we could just add in whatever we needed. What's the other key difference? Oh yeah, instead of just plain old x squared, I've got 5x squared. So we need to deal with both of these issues before we can complete the square. Let's deal with the constant issue first. That's a pretty easy one. We're going to start by clearing out that constant by moving it to the other side. So that'll be a -30 on the other side. And then to get rid of this 5, we're just going to divide by whatever this a value out in front is. So we moved our -30 over there. Now I'm going to divide everything by 5. And that'll just give me x squared minus 4x equals -6. So now we're back to pretty much the starting point on the last example that we did. Pause the video, and following the steps on that last example, see if you can finish completing the square on this one. All right, so remember we have to take half of the middle number here, half of the x coefficient, so -2. We have to square that and add that to both sides. Next, we're going to factor the left side. This will just be x minus 2 squared. See how easy it is just to move that down into a squared parentheses? And then we have a -6 plus 4 on the right side. Let's simplify that now. We've got -2 on the right side. Now we have to square root both sides. So we're going to have x minus 2 equals plus or minus square root of -2. But wait a sec, what's the square root of -2? Oh yeah, we need to take an I out to make that I radical 2. And then, one last step, we're just going to add 2 to the other side. So x then equals 2 plus or minus I radical 2. Now these problems have gotten progressively crazier with the answers. The last problem we could not have solved at all by factoring, because there was radicals in it. This problem, you could not even solve this problem by graphing this thing out and using your graphing calculator to find the zeros. I is not on the x-axis anywhere. So this is one where we can still solve it with completing the square, even when pretty much every other method out there fails. All right, here it is. Final boss battle problem for completing the square. Pause the video and see how far you can get on this one. All right, so first step, let's clear out that constant, move the 5 to the other side. After that, we don't like this 2 next to the x squared. It messes up completing the square, so let's divide everything by 2. And here's where we run into a little bit of an issue. So we got x squared plus 3 over 2x equals 5 over 2. And yeah, when people see fractions in a math class, they typically scream and run the other direction, and that just does not make our lives easier. This is the point in the problem where we're supposed to take half of the x coefficient, square it, and add it to both sides. Well, how do you take half of 3 halves? So when you're taking half of something, you're actually multiplying it by 1 over 2. So to do this, you're just going to either multiply this by 1/2, or you could just think of this as doubling the denominator. If you double the denominator, that's another way to take half of a fraction. So then our magic number is going to be 3 over 4, which we will square and add to both sides. Well, it doesn't get any easier because now we have to keep dealing with these fractions. On the left side, we can factor this. This will be x plus, and this is why it's nice having this in here. We can clearly see we want x plus 3/4 in our squared parentheses. On the right side, we're going to have to get a common denominator. Let's at least square this first, though. So this will be 9/16 over on the right side. So there's our left side. There's our right side. And now I'm going to have to add these together. Common denominator for these two would be 16. So if I multiply this first fraction by 8 over 8, that'll give me 40/16. And then if I add the 40 and the 9, that's 49 over 16. Yay, fractions. Let's keep going, though. We still have to square root both sides. So that'll give me x plus 3/4 on the left, and plus or minus, and here's actually where it's kind of nice. We've got square root of 49, which is 7. Square root of 16 is 4, so plus or minus 7/4 on the right side. I mean, I'm not saying it's super pretty, but at least there's no radicals left, right? And then, as a last step, sort of, let's subtract the 3/4 to the other side. So we then have negative 3/4 plus or minus 7/4. Now, you remember what we said in the beginning, right? If you are able to combine these two numbers, you are obligated to do so. The good news here is that we have a common denominator already, and it often works out this way when you complete the square. So we have negative 3/4 plus 7/4. That's going to be 4 over 4, which is really 1. And we have negative 3/4 minus 7/4. That's negative 10/4, which we can reduce to negative 5 over 2. So there are our two answers. It turns out if you get rational answers, it would have been possible to do this by factoring. But completing the square, I mean, it's a lot of steps, but it's always the same number of steps. So there's at least some consistency there. So congratulations, you have just completing the square. Till next time, this is Mr. Sutton signing off.